will be to guess the parameters m and c, and then we will measure how close they are to the actual data, right? So the strategy is to guess, right? We will guess our parameters. Really, if you look at other machine learning explanation, they will call it random initialization, which is just the same way of saying guessing our parameters, right? So let's say we guess our m to be, let's say, well, let me do a wrong guess first, a bad guess, and then we will do another guess. But really, when we are guessing, we don't know the actual value, so we are just guessing. So any number is good enough, right? So I have taken these two values, and now I want to check if this is conforming to this data. Now, how can I know? How can I know if these parameters are modeling our data correctly, right? This is our question. And if we can answer this question, well, that can help us decide the parameter values. But if we cannot do that, then it will be really hard. So how can we measure if our parameters are correct or not? Well, what we can do, let's do something. Let's say I have this equation, line equation already. Let me put the value of m and let me put the first data point. So what is x? Well, my x is 4. And what is c? Let me put the value of c, right? And let's see what's the output. Let's see what's the output. Well, it's 3.8, right? It's 3.8. And the actual output is 5. So we have some discrepancy, right? So it's not the actual, right? The actual output. So how far is it? Well, it's 1.2 points far from the actual output. Can we compute this for every data point? Well, let's try, right? So let me iterate through whole data, right? So for, let's say, let me call it x and y in data, and then we have to compute this line equation for every point, right? So just simply put our guess parameters m, and then we put x, and then we put c, and this is the value we are predicting, right? So this is our prediction. And the next thing is we also want to compute the error, right? So how can we compute the error? Well, we will see the actual value which is coming in y, right? Y. And we will take the subtraction of these two guys, and this will give us the error, right? And now we want to know what is our actual value, right? Then we want to know our predicted value, and then finally we want to know our error. And if you know Python, you will probably guessed I have to just put the actual value first, which is y, and then predicted value, which is my prediction. And sometimes people will call this y hat, right? Y hat is also a name you will see in the literature, and this is my error, right? And now let me run this code to see. Oh, I have some error here. I have to run this cell. So yes, okay. So now you see that I have a fair idea of how well I am doing when I am using these parameters. But what if I change this parameter? Well, this error will change, but it's really not easy to look at this whole thing and guess from it what is how good these parameters are. So let's do one more thing. Let's compute the total error. Okay, so let's say the total error is 0 at first, and now with each iteration I am summing the error, right? And finally, rather than producing this whole thing, let me comment out this guy and let me just print total error. And let's see what is our total error, right? And it says 29.4. Well, let me change this parameter to see if I can do better. Well, it's increasing, so it's when I decrease the value, when I'm increasing the value of m, the error is decreasing. What if I make it too big? Well, it's, sorry, I wanted it to be 20. Well, it's getting negative. No, I don't want it like this. Well, let's do 1.2. So really the error is changing, but I don't know yet what will be the optimal value for this parameters, so this error is reduced, and that's what we will do in the next video, right?